In this video, we are going to discuss trigonometric ratios up to transformations. Problem number 9, second bit. If a plus b plus c plus d is equal to 2 pi, then prove that cos 2a plus cos 2b plus cos 2c plus cos 2d is equal to 4 into cos of a plus b into cos of a plus c into cos of a plus d. Now, in the solution, given that a plus b plus c plus a plus b plus c plus d is equal to 2 pi. So a plus b plus c plus d is equal to 2 pi. And taking LHS here, so LHS is given cos 2a plus cos 2b plus cos 2c plus cos 2d. See, observe, if you take the first two terms here, suppose, so this is like cos c plus cos d, these two are like cos c plus cos d. So we have the formula for cos c plus cos d is equal to, so cos c plus cos d is equal to, so we have 2 cos c plus d by 2 c plus d by 2 into cos c minus d by 2 into cos c minus d by 2. Now here c is to a and d is to b. So that's why which is equal to 2 cos, so 2a plus 2b by 2. So into cos 2a minus 2b by 2. 2a minus 2b by 2. And again here, the next two terms are also like same cos c plus cos d only. Here c is to c and d is to d. Here also you can apply the same formula, that is 2 cos. So 2c plus 2d by 2. So into cos. So 2c minus 2d by 2. See, if you observe here, in the numerator, in all the terms, if you take the 2 common, then 2 gets cancelled in the numerator and denominator. Here 2 gets cancelled in the numerator and denominator. We get 2 into cos of a plus b into here cos of a minus b, cos of a minus b plus. Here, if you take the 2 common, 2 into cos of c plus d into cos of c minus d, into cos of c minus d. See, observe here. So we require right hand side cos of a plus b and a plus c, a plus d. So now in the first term I am keeping as it is, this cos of a plus b writing as it is. So into cos of a minus b, cos of a minus b, and plus 2 into cos of, so c plus d. See here, so which is equal to, we can write, so c plus d is equal to, from this condition, we have a plus b plus c plus d is equal to 2 pi. So from this c plus d is equal to, we can write, so 2 pi minus of a plus b, 2 pi minus of a plus b. So that's why c plus d is replaced by 2 pi minus of a plus b, minus of a plus b. And this cos c minus d is writing as it is. Cos c minus d is writing as it is. So now here we know that it is in the form of cos 360 minus theta here. So cos 360, otherwise cos 2 pi minus theta, belongs to the fourth quadrant. In the fourth quadrant, cos is positive, so that's why we get only cos theta. So here, so this 2 into cos of a plus b is writing as it is. Cos of a plus b into cos of a minus b into cos of a minus b, and plus, so 2 into this cos of 2 pi minus a plus b, so is nothing but like this property. So we get 2 into cos of a plus b only, this is. So theta is here a plus b into cos of c minus d we have. Now if you observe, in both the terms we have 2 into cos of a plus b is common. So that's why taking 2 into cos of a plus b is common. Then what is here left over? We have cos a minus b, cos a minus b. So plus here, so cos of c minus d, cos of c minus d. See, observe here, again this is like cos c plus cos d only. Here c is a minus b and d is c minus d. So once again we have to apply the same formula, that is cos c plus cos d formula. So which is, so 2 cos c plus d by 2, that is 2 cos. So c is a minus b plus d c minus d by 2 here, and here into cos of a minus c minus d by 2, that means a minus b and minus of c minus d, so whole divided by 2 here. So now here 2 into cos of a plus b is writing as it is, 2 into cos of a plus b, so into here, so 2 into cos of a plus c, first positive values are writing 2 into cos of a plus c, and here minus b minus d, whole divided by 2. So here cos of a minus b and minus c plus d, here minus into minus is plus, so that's why a plus d and minus b minus c is writing here, cos of a plus d and minus b minus c whole divided by 2 here. So now if you observe here, so a plus c here, a plus c and a plus b plus c plus d is equal to, we have 2 pi. So from this here, so we have to get the values in terms of a plus c and a plus d in the right hand side. So now here I am applying that a plus c minus 2 pi, a plus c minus 2 pi, so which is equal to minus b minus d, Similarly, for the next term here, a plus d is equal to, now a plus d also is equal to, a plus d minus 2 pi is also is equal to, so we can write here minus b minus c, see, observe here. So a plus c minus 2 pi, so is equal to minus b minus d, and a plus d minus 2 pi is equal to minus b minus c. Now in the first term minus b minus d is replaced by here. So 2 into cos of a plus b, so into here 2 into cos of this a plus c is writing as it is. So in place of minus b minus d, plus a plus c minus 2 pi you have to write. So plus a plus c minus 2 pi whole divided by 2 here. Again here also cos of a plus d, and minus b minus c, in place of minus b minus c we can write again plus a plus d, minus 2 pi whole divided by 2. So like this we can write. See here, minus b minus c is replaced by plus a plus d minus 2 pi there. See here, which is equal to 2 into cos of a plus b. So into here 2 into cos of so a plus a, that is 2a, plus c is 2c minus 2 pi whole divided by 2 into cos of again a plus a is 2a and d plus d is 2d and minus 2 pi whole divided by 2. So we get. So now if you take here, if you write this is 2 into cos of a plus b is as it is into, so 2 into cos of if you take 2 common in the numerator, then we get here, so a plus c minus pi, numerator and denominator, so 2 gets cancelled, and again here cos of a. So a plus d minus pi. So we get, so in the numerator and denominator 2 gets cancelled. So finally we get 2 into cos of a plus c minus pi, and here cos of a plus d minus pi. So now which is equal to, further it can be written as 2 into cos of a plus b into 2 into cos of, here taking minus common, this can be written as minus of pi minus of a plus c. Here a plus c is one term and pi is other term. In both, if you take minus common, it can be written as cos of minus of pi minus a plus c, we can write like this. And again here also a plus d is one term and pi is other term. If you take, so minus common, minus of pi minus of a plus d, pi minus of a plus d, we can write so like this. So like this, if you take the minus common, cos of minus of pi minus of a plus d, we get. So now which is equal to 2 into cos of a plus b, and here 2 into cos of a. So cos of minus theta is always only cos theta. Cos of minus theta is always only cos theta. So that's why this is 2 into cos of a. So pi minus of a plus c, this is pi minus of a plus c into cos of, this is also pi minus of a plus d. Pi minus of a plus d. See, observe here, now it is both are in the form of like cos 180 minus theta. Cos 180 minus theta is always minus cos theta. So that's why which is equal to 2 into cos of a plus b into, so this is 2 into, so this is minus cos of a plus c, minus cos of a plus c. Again this is also minus cos of a plus d here into minus cos of a plus d. See, observe here, minus into minus becomes plus. Now if you multiply this everything, you get 4 into cos of a plus b into cos of a plus c, cos of a plus c into cos of a plus d. Here minus into minus becomes plus, 2 into 2 is 4. Finally we get 4 into cos of a plus b into cos of a plus c into cos of a plus d. So which is equal to RHS. So therefore LHS is equal to RHS. So that's why like this we can prove that cos 2a plus cos 2b plus cos 2c plus cos 2d is equal to 4 into cos of a plus c, b into cos of a plus c into cos of a plus d.